Good morning, everyone. Welcome back to the OpenShift Coffee Break show after this nice music for our starting soon. Today, I'm really excited to restart our Coffee Break series episode with our fantastic Jafar. Hey, how are you, Jafar?
Hey guys, how are you?
Hey,
Nice to meet you.
There's a train. What is?
That's an airplane flying on my head. Don't worry.
Oh, okay. Hey, Fabio, welcome back. How are you?
Morning, guys. Happy New Year.
Happy New Year. Hey, welcome and back, Andrea. How are you?
Good morning. Happy New Year from London.
Hey, and last but not least, our super guest of today, Luigi. Luigi is an ex-redactor, great buddy. We had lots of fun in workshop, demo, presentation, events. And Luigi today is solution architect at Red Hat, but I'll let him present himself. Hey, Luigi, how are you?
Hi, hello everyone. Good morning and Happy New Year to everyone. I'm very good. What about you guys?
Not bad. In this start of the new year, where we have some good news, Jafar, to share. So basically, we start this is the start of the new series about the database as a service series. We will focus in a series inside our show, our Coffee Break show, talking about how people can use a database as a service on top of OpenShift. And we're getting more and more in a cloud service mode. Today, we will see together with Luigi a nice demo on how to use Redis databases on top of OpenShift. And this will be the first episode of this appointment with Redis. In the second one, Luigi will talk also about the database as a service integration. And the second news, Jafar, is that we're gonna go weekly into a weekly base. We have also Fabio, Andrea helping us. So I think it's great. After our last year, we have lots of fun, but this year, I think we have more content. What do you think about it?
Yeah, that's very nice. I think the more we are, the more fun we can have, and the more, I would say, interesting topics we can share. So welcome to the show, guys, and it's great. And a happy New Year, everyone, because there was the plane, so I couldn't.
Oh yeah, but who has the plane?
All right, so great news here, and let's share a sip of coffee before.
Yeah, please, folks. This is OpenShift Coffee Break. The idea for people that joined for the first time, the idea of this show is that we share a coffee together as we used to do. Talking about the office, about a little break, talking about anything. And the best idea came properly from that coffee break. So we would like to repropose in a, let's say, a virtual, but also more broadened version, this virtual coffee break with everyone. So we're going to talk about architecture, cloud native, Kubernetes, and OpenShift. And of course, with live demos. Luigi, what do you think of this live demos approach?
I think it's the more natural approach. I mean, you cannot lie, you're live, and then there is, of course, all this kind of excitement because you're live, it's not recorded, it's more, I think, it's the best way to do webinar presentation and doing also live coding or whatever it is. So I prefer live.
It's like a theater versus the movies.
Yeah, exactly. Yeah.
Yeah, and you have to know that Rich is a great presenter. I remember the conferences we had in Red Hat, like CS Kickoff or Red Hat Tech Exchange. Luigi made a really great presentation. I'm sure he's doing great as well here.
Keep it low profile.
Low profile. And Luigi is also book author. We can share his book in the chat if you want to hear more about his work on what he does. So Luigi, I gave to you a great presentation. Please,
too much.
Please deliver.
please let us know.
It's time.
So, yeah, the topic of today is how we consume databases on Kubernetes at ease. And we think we created a good environment where we have an OpenShift cluster. In this case, we prepared an environment with a ROSA cluster, which is a Red Hat OpenShift on AWS, is our managed OpenShift offering. and Redis operator, but Luigi can tell us more and more about it. I think you have some slides, maybe.
Yeah.
Yeah.
Yes.
Okay, cool.
I don't know if they are already visible.
Let's check.
There should be.
Oh,
All good.
I can see them.
Okay, excellent. So this is actually a first in a series about DBaaS, so database as a service, and we will be focusing on Redis Enterprise on OpenShift and see how actually Kubernetes platform can deliver DBaaS by nature, by design. And as already mentioned by Natale, I'm Luigi Fugaro, Solution Architect at Redis, and that's today's agenda. So we will first focus on what's actually is DBaaS, and then we will see Redis Enterprise Cloud, and then we will have a deep dive with Redis Enterprise on OpenShift. And then together with Natale and I will do a demo, a live demo, so cross fingers, and then a few recap, so takeaways, and then what's next, what to expect in the next episode of this DBaaS series. So what is DBaaS? First of all, it's an acronym that stands for Database as a Service. So as you can imagine, DB stands for the database. But if you think about the as a service model from the cloud offering, DBaaS is actually the ability to deliver a database in that as a service model. And what does it mean? Before we can understand the DBaaS, we need to properly understand the traditional way of provisioning a server database, a database server, so a platform. And probably you start by buying some hardware, and on top of that, maybe installing an OS, most likely a Linux server, and then of course you install your software for the database platform of your choice, your favorite one. And if you think about this, there is a lot of work that, of course, you can automate, you can script it, you can use Ansible, Terraform, whatever automation tool you need. And so this is not really the hard part. The hard part behind provisioning a database platform is make it run and keep it running available all the time. So 24/7 for the servers, for the OS, and of course for the software, for the database software platform. And of course, there is also more that you have to do. So the real challenges comes when you actually accept your user to log into your system. So you have kind of different users depending of the access they require. Might be a system administrator, a server administrator, a database administrator. They all need different kind of capability, permission, roles. Maybe you do some airbag things or ACL. And then you still, when you own your database platform, you also need to be aware of updating maybe your hardware, the hardware itself, maybe the firmware of the hardware, the patching the OS, and then of course patching the database platform for to cope against any security vulnerabilities. So you may encounter separation of duties between all these kind of personas, as I said, server administrator, Linux administrator, system administrators, DB administrator. So you need to probably hire some specialists to manage all these, to operate your infrastructure and your architecture. But what actually means managing and operate a database server as a platform? It means that also if something goes wrong, you have to cope with it. So you probably need to manage your crash of the server, of the OS server, or the database software that maybe crashes. So you need to have backups. So you need to restore them very quickly because maybe you're running a production workload. And so you need to restore everything as soon as possible. You need to think about high availability, about the storage, the persistency. So there is really a lot of work. Automating the whole thing is just one side of the coin, and there is also another part which is managing the whole thing. So DBaaS, that's the real benefit of having a database as a service, where all the challenges are actually delegated and shifted to the database as a service platform. So it could be any cloud provider. So they will take care of the installation, of the security, of the operations, of the patching, backup, recovery. And all you need to do is, hey, just give me my database. I want that specific database platform, give me the endpoint and the credential, and I'm done. So the real difference then between running your own database and actually relying on a DB as a service, it's that with running your own, you have great power, of course, and of course comes great responsibility. But you also can have this tweaking and tuning all your settings and to run the system faster, the database faster. You're actually on your own, and you can do whatever you want, in the goods and in the bads, of course. With a DBaaS, you don't need to think about all of this. There are people that are managing and to make the database of your choice run faster. And then, of course, once you ask for your database for the endpoint and the credential, then you need to agree and you ask for some kind of SLAs, like if you need 3 nines, 4 nines, 5 nines, whatever you need, they will work for you and they will manage the database platform for you to achieve and to meet these goals. And they also need to guarantee that the DBaaS is always up, always available. You may require a specific use case like active-active, where you have different database platform in cluster, both active and different, maybe distributed locations. So DBaaS is really here to help. And of course, Redis Enterprise has its own proposal of the DBaaS, which is called Redis Enterprise Cloud, which runs on top of the major cloud providers such as GCP, Azure, and AWS. Of course, can be provisioned using also Kubernetes platform like the OpenShift, Red Hat OpenShift. So what is all about? Of course, one of the best solution to deploy a platform on Kubernetes is through the operator. So in Redis Enterprise, we have an operator, which takes care of pretty much everything, and it deploys a stateful set, deploy the pods, deploy the services, it's all a bunch of things. That's actually here is a high-level overview of what can do the operator for us, but this is actually drilled down how it works. So we have this operator which creates a couple of custom resources definition files, which are the Redis Enterprise Cluster Custom Resource and the Redis Enterprise Database Custom Resource. And once created, they create, of course, the operator takes care of creating the secret to access and to manage the cluster, creates the stateful set, so it provisions the stateful set around the OpenShift nodes, create the service to access all these resources and the UI, and then also provision the secret to access the database. And the difference between, for example, we have two manifests to custom resources. One is for the Redis cluster, where you specify actually the size of the cluster in terms of the number of nodes, the size of the nodes, how much RAM, how much storage you need. And then we have the Redis Enterprise Database Custom Resource, where you define settings for your database. How much RAM does it need? Which kind of storage class does it need? What kind of persistence volume to use? It will automatically attach those persistence volume with persistence volumes claims. And so it does all the things, all the so-called day 2 operation for you. And there is also another component, which is the service rigger, which actually, whenever the operator identifies and discovers a new database, automatically calls the service rigger, which creates the service on Kubernetes, and then binds the service through with the application workload, so your application or your client, so to speak. And there are many settings that you can, of course, use when building your Redis Enterprise cluster. So this is just a manifest as an example with 3 nodes, the name, the kind of service type that we're going to use, like a cluster EP, the memory to be used. This is actually, if you see, like 4 gigabytes is actually the memory for that Redis Enterprise cluster node, which is built on top of any other of the OpenShift nodes. And all other things like the kind of storage, the images, the version of the images, and so on. Once everything is up and running, and then you can access the Redis Enterprise UI, where you actually have a bunch of information regarding the cluster, regarding the nodes, and of course also information regarding how to create a database. So there is a nice user interface to create a database with a bunch of options. And also there are a lot of metrics that are exposed via Prometheus, but also directly in the user interface, you can see all these metrics. Going back to the OpenShift, those are the samples of Redis Enterprise database manifest files. Here on the left, we have like a small database where you actually have 100 megabytes of RAM with persistence enabled, which actually does a snapshot of what is stored into Redis every hour, and there is a shard count. So the workload of your dataset volumes are distributed among two shards. There is a lot to talk, of course, about Redis, about OpenShift, but this is just the first introductive live webinar of this DBaaS series. And on the right side, we have the full specification of the manifest, and so all the options that you can use. And in regards to the deployment, as you know, on Kubernetes and so on OpenShift as well, we have the so-called namespace project for OpenShift. So how you can create the Redis Enterprise cluster within OpenShift. You can relay the entire cluster into a single project with a single database, or of course you can have a single into a single project. One cluster with multi-tenancy enabled. Multi-tenancy means you can have different databases within the same cluster. They are completely isolated. They have their own error bug and SCL things. So every database has its own endpoint. And of course, we also provide the multi-project and multi-tenant deployment. What we do not support is having into a single project multiple cluster. This is not allowed also for because also of the naming convention and so on. And so without going too much in details in this, maybe it's time to starting with our demo. Natale?
Before that, Luigi, I would like to first thanks for this great presentation, because that helped understand how we can manage, databases in Kubernetes are something that if you tell to people, hey, what about database in Kubernetes, they're going to say, I don't know, because there's a complexity, that you have to manage. But the operators is the really first-class citizen in Kubernetes, helps managing events, the life cycle, the reconcile loop, the reconcile loop of the Kubernetes lifecycle management. So you can deploy your topology as you are showing here with the single tenant, multi-tenant, active. So this complexity of deploying and maintaining stuff is managed by the operator.
Exactly.
And that makes the thing easier and native to Kubernetes. So I think this is the big plus. The second big plus, Luigi, I would like to mention. You show us Redis Enterprise, but I want to mention that Redis Enterprise is also a certified operators in Red Hat marketplace. So I'm going to share also in the chat the link of the Red Hat catalog, where you can look for any software, in this case for Kubernetes packaged as an operator. So if you look at the link I put in the chat, you can see that there's a Redis Enterprise operator, and this is the one that Luigi was talking about, right? So
yeah.
In fact, maybe I can just really quick show it. If you click on that link, you should go in this view over here. So the Redis Enterprise that Luigi was talking about is a certified software for OpenShift, and when you click here, you can start deploying it and using it inside your OpenShift cluster. There's the documentation, there's all the steps, the component. So there's a list of certified software for OpenShift, and Redis Enterprise is part of it. So it's really cool that we have also an ecosystem of software which is certified and packaged as an operator, as in this case. Of course, you can use either enterprise and community operators. It's up to you. But if you want to use Redis Enterprise, you can use on top of OpenShift because it's a certified operator.
Yeah, thanks, Natalia. Also, what the Redis Enterprise operator does, it also enables you to use admission controller, where it can actually, it validates your database manifest files before you deploy them. It validates and checks everything. If everything is compliant to your rules, then it gets deployed. And so the operator manages the whole thing: day one operation, day two operation, maintenance update, rolling update, everything for you. So there is really, as I say, this DBaaS nature on OpenShift that you can use, because at the end, once you ask for a database on OpenShift, you will just get the endpoint. So really a database as a service.
Right. Oh, before we move into the demo, which is the coolest part, no? Any question from you, Fabio, Andrea, Jafar? I see in the chat there's people that's joining. Hi, everyone. There are also Luigi fan, I think. There's lots of people for Luigi, so that's great. That's why we invited you. And yeah, any thoughts, folks?
Yeah, just a question regarding a topic that is usually very crucial when we speak about database running on OpenShift. It is the consistency. Anytime you have a database running on OpenShift, people is worried about what happened when a node goes down or stuff like that. So I'm pretty sure that the Redis operator is able to manage this kind of operation. But if you, Fugaro, Luigi, can you provide us some more guidance, details?
Yeah, the operator actually watches for everything that happens in the Redis Enterprise cluster. The Redis Enterprise software actually has an automation mechanism that watches all the instances, all the shards, and whenever something goes wrong, it triggers the failover of that particular instance, node, whatever it is. So once you, for example, if you lose a master, automatically a replica will be promoted as a master. So there is no interruption in terms of client connection. There is no data loss. There is nothing that happens in those kind of situation. And of course, there are also mechanism that once a node actually comes back, you can also have those kind of failback to remigrate eventually all your data set to that specific node, if that node has some particular, I don't know, much resource in respect to the other. But this is something that of course you can trigger at your own whenever you want. So this is actually all these automations are because of the Redis Enterprise. With the Redis open source, it's a bit different. You have to do it manually. You have to configure different components. So it's a bit tedious. With Redis Enterprise, everything is done with the operator on OpenShift.
Okay, thanks, Luigi.
Yeah, so I'll have another question, but maybe we can keep the answer for after the demo. What I'll be interested in is to understand your main use cases, like for what use cases your customers mainly use Redis. If you have something that can explain that, that would be,
Yeah.
What are the strengths of Redis when you are, in an application architecture, I would say.
Yeah. Okay. Thanks for the question. And first of all, everyone knows Redis because of the cache, because it's for performance, sub-millisecond performance, and inside the cache, everyone mostly used to store session tokens, all this. So all the components and things related to authentication, authorization. So to quickly have all this kind of things. But nowadays, especially with the event-driven architecture, and back in the days when the enterprise service bus were everywhere in the enterprise architecture, we see Redis adopted also as a messaging system, because implemented the pub/sub model, also implements the stream, which is a native data structure in Redis, and so you can stream all the events within Redis. And then lastly, we are seeing the adoption of Redis also for CDC, so change data capture use cases. So to receive those updates from let's say legacy database, and then bring everything at on Redis, and then eventually redistribute with messaging notification or with stream to other system of the architecture. Those are mainly the the use cases where you see the adoption of Redis Enterprise. But can be really, in terms of industries, any industries as a use case that can be done with Redis.
Okay.
Also because the Redis architecture is very easy to set up, really no less than an hour. So it's really simple.
Very nice, thanks. That's new information, because I wasn't aware, for example, of the CDC part of Redis, or even the second use case, which seems like an option to Kafka, for example. Is that correct?
Yeah, exactly.
Okay, cool. So
Yes.
thanks, and now we can proceed with the demo.
Now show us the code.
Yeah.
Talk is cheap. Show us the code.
Okay, so let me.
So just to give a quick context, we prepared with Luigi, we gave to Luigi an OpenShift cluster. This is a managed OpenShift cluster on ROSA, Red Hat OpenShift on AWS. We created from the hybrid cloud console, so it was very easy to create this cluster and prepare the cluster for the demo. So this is a 4.9 cluster. That means Kubernetes 1.22. And for the demo, as Luigi we will show, we will use this environment with an operators and a nicely bundled app and coded app by Luigi. Yeah.
Okay. Can you just drive me through the interface, Natalia, if you
Yes.
or if you want to?
No. This is if you wanna. One thing I wanted to show to the people is that if you go to operators, down, and you go to installed operators. So this is the operator. If you click Operator Hub again on there, so this is the Operator Hub, which is our marketplace inside the cluster, where you can pick your favorite software and use and order. In this case, with Luigi, we ordered at Redis database. Luigi, if you look for Redis here, what we installed in our demo is the community operators, which is a Redis community operator. What we did is just install the operator, and then we will be able to consume it in in the demo. As you know, Luigi, this is the, let's say, administrator perspective. Then we have the developer perspective, where we can show how developer works. And then we can pick any of these namespace at our convenience.
Okay. Let's go with coffee break.
I hope we clean it.
If we didn't, we will now.
In the while, the WebSocket kind of try to reconcile. If you look, if you click on the observe item on the left, in the left side menu bar, if you click on observe, so here is cool to have also the metrics of all our application. So those are Prometheus extracted metrics. So a developer can look at the application and then look of all the sets. In this case, Luigi, we created some cluster from the operator. It's cool that you have also this metrics overview where you can check all the setting, and you can manage alerts, events with Prometheus.
Yeah.
Okay. Back in topology view, I think what we did already was to create the operator and to create a cluster from the operator custom resource. I don't know why. Maybe if you try to refresh, I think it's something with the WebSocket and Chrome.
Yeah, sometimes happens.
Live demo effect.
Yeah.
Let me check if I have also the same issue. Let's see.
Okay, we didn't clean.
Okay, we didn't clean. But Luigi, we can create a new project and work from there. No?
Okay, sure.
This was the final result.
Yes, exactly. So let's go back to.
You can, yeah.
So how about you show us the end result, and then you describe how you achieve that?
Yeah.
If you want, or if you prefer not, I mean, do what as you like.
Yeah, no, just because this is the final result, Luigi, you know? What we did is just using the Redis operator to create a standalone cluster.
Okay.
And then we used the Redis operator to create a Redis cluster with 3 replica. In fact, Luigi, if you go back into the administrator perspective and you go to operator, installed operator, if you go to the Redis operator and you go to all instances, here, if you see, we created those Redis instances just using the operator custom resource. So those clicking on one of these, it's just a custom res, it's YAML file. If you click on YAML, describing, hey, I want a Redis cluster with 1 replica in this case. I want to start from this container image. I want these settings. Similarly to what Luigi showed about Redis Enterprise, which has more settings, right? More control. In this community, we just created this Redis cluster for our demo. Yeah. Luigi, you wanna? How do you want to? I think we can create a new project with a new application. If you.
Natale, there is an advice from Sebastian in the chat, is suggesting, Sebastian Blanc, suggesting that probably going back to admin perspective and then back to the dev should fix the little topology view bug. Just
okay. Thanks, Sebi.
Cool.
Okay. Yeah, so Luigi prepared an application. I'm going to share in the chat the source code of this application, so you can, and Luigi, you can also share in the screen your application, just to show to the people which application we're going to use for the demo. I put the link in the chat.
Okay, let me
you
go
can show
to the chat.
In yeah, you should see. I can also send you in the private chat if you want.
Yeah, that's better.
Let me send you there, private chat, and so you. Okay. This is the link of the repo used by Luigi, creating the sample application, which is a sample application we use for deploying our stuff. And as you see, Luigi, we prepared this application, no?
Yeah.
We prepared this with a Docker file. Maybe we can just go into the curl commands, since we showed everything. So what we did yesterday together was, okay, we deploy an application on OpenShift with the web console, and the web console recognized that there's a Docker file, and we used one of those Docker file with a multi-stage build to create it. Now we want to show that the connection with the database is working with the database we created, and we also used the service binding operator, which is another functionality in OpenShift and OpenShift Web Console that allow you to bind an application to a database just with the drag and drop on the Web Console. I'm gonna also share in the chat the link of the service binding operator. And the Ops3 Redis community is one of the supported operator that allow this automatic binding. In our case with Luigi, we were using an environment variable just to say, hey, connect to this Redis cluster. And we could make it on with the visualization thanks to the service binding operator.
Okay, let's see if I have the, okay, Redis standalone. That's the service to use, right?
Yes. So here you gotta connect to the Redis database endpoint, your application.
Okay, Redis database.
And the port using by the service, which is the 8080.
8080, of course.
Can you increase a little bit your font, Luigi? So because we have an embedded view in our stream.
No.
Okay. Oh, maybe it's too much. No. Okay.
I was trying to. No, it doesn't. Let's. Okay. Let's first try like this.
Okay. Because we are not using the fully qualified. Maybe Luigi, we can use just the route, the OpenShift route, which is that if you go down, is the URL exposed outside, and also if you share, if you share in the chat, in the private chat, I can share to the people so the people can see that the application is up and running in our live demo, and they can check it.
All right, just a second.
Yeah. Now you need to add the endpoint.
Yeah.
Luigi.
Oh yeah, we missed the slash API.
Yes.
Slash API movies. Yeah.
Let me.
And Luigi, just to give you pressure on this live demo, just because we want to give you pressure, can you extend a little bit this terminal up so the people can see?
This one?
Otherwise, no, go. If you pull a little bit up, yes, this way.
Okay.
Okay. So the people can see because there was your name on left side.
Now, still doesn't, of course, during the live.
Okay, ready. Are we sure we use the HTTPS? Yes.
So if you want to do a post, you don't need like a username or a token or something?
No.
No, this was content type, Redis.
What are we missing?
API movies. I cannot see good the wall because there's your name on top. Maybe you.
Yeah, what you can do if you open in a new tab like you did before.
This one?
Yeah.
Okay, this is gonna be better.
Much better. Yeah. All right. So let me. So it is. Redis, this one.
Yep.
Copy. Let me, in the meantime, copy in the chat.
So just one question.
Sure.
I saw in your curl you were using an HTTP endpoint, and the route is HTTPS. Is it a problem or not?
No, that's fine.
Oh, that's fine. I think. Let me check also over here. Maybe it's just a copy and paste stuff. Oh yes, Luigi, is a copy and paste stuff because I was able to do from my terminal. Okay. Let me copy to you in the private chat. It's yeah, it was a copy and paste issue. If you go to the private chat, I have the right one.
Okay, let me.
So I think. So did you create the route to point directly to the endpoint, to API movies?
No. And in my copy at the.
Because in your copy we don't see the.
No, yeah, it's not copied. This copy and paste doesn't work.
Okay.
Yeah, maybe where I can send you. Luigi, just add the /API/movie because it was removed by my copy and paste for some reason.
Okay. Then it should work, right?
Yeah, API movies.
Oh, there you go.
Okay, yeah, it was a copy and paste. Sorry about it. Yeah, sometimes it happens.
No, still.
404. This is weird because
yeah, it is. Is it up and running?
Yeah, check the pod and see if it didn't crash or something.
Okay. If I do from my terminal, and I can show you that I'm not crazy. Let me show you quickly. So share screen.
I should interrupt my sharing.
No. I can just switch mine, and you should switch off yours. So if we go here, no, let me clear it. Hiding. So curl gulp year 22 to 2020, Redis database, coffee break, blah, 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 API movies, and it's going. So I'm uploading some stuff. Let me go silent here. Status, bad request. But here it's a 201, yeah. 201, yeah. Here, as you see, it works, and I think if we go to the endpoint, and Luigi, what was the endpoint? Was it movies? Yes. You see, we have our endpoint. So maybe Luigi, you can just use not that terminal. You can use your own terminal. And I'm going to give you back the sharing.
No, yeah, I tried, but it doesn't work. Yours works.
Yeah. Let me do this quickly. Let me share with you on Telegram the command. Okay. And please try this on your terminal, not on the web terminal. I think it's a copy and paste stuff.
Yeah,
and
now
in
it
the while
works.
works. Okay. No, okay. So now this is me. Let me give you the control again. Yeah, this works. So sorry, it was a kind of copy and paste issue. And if we go here, we should see all the items
there you
that
go.
we used. Yeah,
We did it.
Cool.
Finally.
Yeah, sorry. Sometimes happens copy and paste kind of stuff. But Luigi, the flow. What was the flow? If we go back to.
So basically, what we did is actually we deploy this with the source to image, so connected directly to the GitHub repo, and then the OpenShift did the magic, and then we just drag and drop the arrow to the Redis standalone instance, and then the application now it's bound to that specific database endpoint, and so as you can see from the curl commands, we can actually enter the data into Redis.
So I have a question regarding how you put data in the database from the application. Is there like a client or an SDK that you can use in the applications, or is it just like a regular post that you do in there?
Yeah, let me show you. Actually, I'm relying on the Spring Data Redis, which actually has inside two Redis client drivers, Redis and Let Use. And so the whole thing actually happens at that level. So I had to specify my movie repository like any other Spring Data repository. I don't know if you're familiar with Spring. And then this actually it's embedded into the controller, which has all the get mappings and post and put and whatever to do all the things. And that's it. That's the only thing that you have to do. And one thing maybe to notice is the Redis configuration, where you can actually tweaking and tuning your database endpoint, where you can actually apply defaults and everything, and then you can specify which connection factory to use, and so which driver to use, eventually how to serialize the values of the object that you want to store in Redis. Right now I'm using Jackson to JSON as a JSON serializer, and so really depends. And then we might also look at the models, which are actually POJOs just annotated with Redis hash. So in this case, it's just a list of attributes and values. And then I also use the @ID annotation. So because Redis is actually a NoSQL database, and specifically it's a key value store. So we need to specify which is the key in this POJO to be used. So
okay, nice.
Nothing really especially very, very easy. And also we just released Redis OM. If you're familiar with the ORM, Object Relational Mapping Framework, we have one for Redis, which drops, of course, the relational thing. And so we have an object mapping just for Redis, and we have released it for Spring, .NET, Node.js, and Python. So it will easy all your coding, just relying on annotation, for example, for the Spring. So very, very easy.
Very nice.
If I can, you mentioned Spring, so we can use also Quarkus to Redis client to leverage the Redis capabilities. Let me share in the chat just a link. So yeah, just to mention our dear Quarkus runtime.
Yeah, I think there are support from the framework like Spring Boot and Quarkus. This is the Redis client. So in the same way that Luigi showed on how to add to a Spring application the Redis support, this is how you can add the Redis connector to a Quarkus-based application. So Fabio, did you share in the chat already?
Yeah, the guides to use the Redis client.
And I also wanted to share in the chat. So we showed with Luigi, there's this Redis application, which is in this case is a Spring Boot application connected to the Redis database. If you want to use the service binding operator, which is the one that in OpenShift Web Console allow you connecting application, avoiding the complexity of managing manually mapping environment variable secrets. There's a library that you can use, and it's this one, the Spring. In this case, it's the Spring Cloud Bindings. And for Quarkus, if you want to use it for Quarkus, actually, there's another library that you can use that Sebi was kindly sharing with me, which is this other one I'm putting in the chat, which is the service binding for Kubernetes. So when you use these libraries, you can allow the connection automatically between the two. And I think this makes easier the life of the developer on Kubernetes without having to struggle much on how to manage connection, how to connect to database. So what we have seen today, I think it's very cool because we have seen how to create a database with an operator. And we have, Luigi showed that how the operator can help you with multiple settings and configuration on deploying such topology. And then you need to connect your application to such database. You have the framework, you have the libraries. So I think it's very cool that we can have this support in cluster. But Luigi, going into the end of our show, I think we have something to anticipate for our next episode together, right?
Yes, absolutely. Let me switch back to the presentation. Okay, just skipping the details about every single deployment, single namespace, single multi-instance, etc. We did the demos, few recap. Just regarding the DBaaS, what you should focus when choosing a DBaaS platform. So again, high availability, resilience, scalability, high performance, flexibility. This is, I think, very important to choose between the on-premise or clouds. I mean, you can have hybrid cloud solution, and I mean, OpenShift that is really well. And now the data are a bit different. They're not just like of type strings or numbers or dates, but we have different data structure that can be used, and Redis provides all these data structures for you. And what's next? So Red Hat Database as a Service add-on functionality, which is what we actually try to replicate here during the demo with a bit of manual operations, where this is actually the same thing. You deploy your application, then you specify, you go to add-on functionality, and then you do connected database. That means we already registered our DBaaS solution within OpenShift, and automatically OpenShift discovers all the DBaaS endpoints, and you just select your database of choice, and there you go. You have your DBaaS endpoint directly into the POP topology, and here again, drag and drop, but for real, without any manual coding or settings, and you just drag it the arrow, and then it gets bound to the database, to the endpoint.
Wow.
So that's I think you guys are going to release this very, very soon, because it's really, really helpful, especially into the DBaaS mood approach. I think this is very, very important.
Yeah, thanks for mentioning it. I had also a quick chat with the engineering and the product manager. So the Red Hat Database as a Service add-on will be available February-ish, and Redis support, we will have Redis support by April, as far as I understood. So that's very cool, because as Luigi was showing here in the slide, basically you connect your application in your OpenShift cluster to a SaaS service. So the Redis database, in this case, which is not in this cluster, but it's on Redis Cloud.
Yes,
just
exactly.
linking dropping this line, connect under the hood, connect the SaaS of Redis Cloud to the application. And I think this will be available on April. So maybe our next appointment, Luigi, to do a second demo, but with Redis Cloud, can be in this timeline here at OpenShift TV.
Yes, absolutely.
Super, super cool. Let me check if we have any question about this. I also share in the chat the link to Red Hat OpenShift database access. This is the new service that allow OpenShift user to connect to any database as a service available for supported in this feature. So you can have your OpenShift cluster connect to any database as a service as the Redis Cloud one, which will be available, should be available by April. So looking forward to it. We don't have an additional question in the chat, but thanks everyone for joining and making interaction. So we have some few minutes left. I was wondering if you, Andrea, Fabio, Jafar, do you have any additional question also about this thing, with the latest thing that we've seen that Luigi discussed about?
Yeah, it's Andrea here. I wanted to go back a little bit when Luigi was speaking about the supported configuration and topologies. One that I would be interested in, and not necessarily for SaaS, but in general, the topology where you have active on two separate clusters that maybe are distributed geographically. I think that was supported, but I wasn't quite sure from this slide if that was the case. I just wanted to ask Luigi if you can clarify that a little bit.
Yeah, absolutely. Thanks for the question, Andrea. Active, it's an architecture that you can build with the Redis Enterprise, where you have one Redis Enterprise cluster on one side, which can be inside OpenShift using, for example, virtual machines, or maybe on the cloud. And then you have another separate cluster, active again, and which may be on premise on whatever infrastructure you have. And all those two clusters connect together and sync the data together. So it can be, of course, distributed geographically, for example, in different cities or different regions, and all the sync happens real time. And Redis Enterprise has a technology which is called conflict-free data replication type, which actually merges and resolves all the conflicts of writing the same set on different clusters together at the same time. So it prevents any conflicts and merge correctly all the data, so you can actually really have two separate clusters active together and without any problem. And this is supported.
I'm going to push the envelope a little further. Could that be used for, like you said, a central cluster with multiple edge clusters that are sharded differently?
What do you mean? Sorry, can you repeat?
So could you have a number of edge clusters that are only responsible for a shard of the data, yet they are replicating to a, let's say, a centralized cluster?
Yeah, well, all the sharded instances of Redis Enterprise has to be in the same cluster, of course, because that the workload has to be distributed in that specific cluster. But the data can be, of course, gets replicated to the other cluster back and forth. So there is no priority where you write, right? So it depends also on your location, depends on the networking. Maybe you are in America, it's better that you use the American cluster rather than the European cluster for, of course, latency issues and so on. So but everything gets synced and replicated together without any conflict. But the data volume, the data set is actually managed by one single cluster.
So actually, let me rephrase maybe the question, Andrea, and let me know if that's what you meant. So, for instance, when we speak about central architecture and edge deployments, usually we try to minimize the footprint on the edge workloads.
Yep.
Andrea, did you mean, for example, you're going to have a full-fledged, highly available Redis cluster on the central, but on the edge you only have one replica or something like that? Is that what you meant?
A subset of the
Oh yeah. Oh, okay. If they belong to the same cluster, yes, of course, you can use also this kind of topology. But the cluster must be within the same cluster.
Okay.
No matter where they are, as long as networks allows latency, bandwidth, and so on.
Okay. Yeah, that's very interesting because
so it's more suitable for a typical active situation where you have two data centers that are replicating among each other and provide high.
Yeah, exactly. There are many customers that want the business continuity, disaster recovery. Nowadays they are switching from they're going away from the active standby, active passive scenario, but they want everything active in both data centers. So Redis here is very helpful.
Thank you.
All right, folks, we arrived at the end of this show. I'm really happy we have the show. We started this database as a series, database as a service series, and we started with Luigi because we have the great conversation, great slides, great demo, great talk, and great question. Thanks also, Andrea, for this question. It was really interesting. I would like to end our show just with some quick reminder. Today, please check our calendar at OpenShift TV to see what are the other sessions that we have today. Today, for instance, we should have the Level Up Hour and Ask an OpenShift admin. So you can stay on OpenShift TV and follow us also in this show. And also, I would like to remind the next appointment. We will keep bi-weekly for January, then we will move weekly by February. So next appointment for us is February 26th, another database as a service episode probably. And also I would like to leave you some reference from Luigi. I'm gonna share his Twitter on the chat. So if you would like to follow Luigi and check news from what he's doing at Redis, that is the Twitter handle. And now, yes, I would like to thank Luigi for this joining us today. It was really great to start this new year series all together with Luigi, Fabio, Andrea, Jafar. Thank you everyone for joining. Thank you everyone for attending. And yes, see you next time. Ciao.
Have a great day. Cheers. Bye.
Thanks. Bye-bye.